Hello, everyone. Welcome to the MIT Mobility Forum. I'm Eva Roos, Professor of City and Transportation at MIT. And today is the 163rd session of the Mobility Forum. And we have two parts of today's session. The first one was celebrating the winner of this year's Roos Award. As you know, Professor Dan Roos and his wife, Eva Roos, very kindly donated funding to MIT and set up this award. The purpose is to encourage the doctoral level research in transportation across any field. So the eligibility is you can from any department as long as you work on transportation related topic. And this year, our winner is Dr. Kamessi Zhao. So she will be the first presenter for today's topic. Also, I want to acknowledge Professor Daniel Fruit, who's the advisor of Kamessi's doctoral study. For that, actually, let me share the screen here to show this. Right. So the Dan Eva Roos Thesis has been running for many years since 2018. This year, I also want to thank Professor Joe Zardini, Professor Cassie Wu, and Surab Amin joining me as the prize selection committee. We have the winner, Dr. Jiayu Kamessi Zhao. We also have the honorary mention, Dr. Yunhan Zheng. Now he's working at Peking University as assistant professor. Then all the prior winners include Baitran Mo, Runak Partek, Shenghao Wang, Asa Wiko, and the first inaugural winner, Gabriel Krendler, listed here. Right. So that's the first part. The second part is each year, MIT Mobility Initiative invite senior fellows, most from the industry, to focus on one particular topic and do an independent study and share the report with us. Last week, we had three. Stanley Pollack, David Zipper, and Cara Kochman report their finding. And today, we have Jamey Tesler and Grosser report their finding as part of the senior fellow research. Right. So lastly, I'll just mention reinforce the norm of this forum, which is for everyone, particularly the audience, to contribute an idea. It could be in the form of a question or comments to the panelists today. Right. So let's start with the first round, where I invite each of the panelists to give us a 30-second highlight, the take-home message here. Jamey, let's start from you.
In 2025, the United States is going to license between 1 to 2 million new human drivers who are going to do roughly 12 to 15 billion miles on the roads this year. Compare that to Waymo, who just crossed the 100 million mile threshold this summer. In short, if you want to reduce traffic fatalities, the highest leverage tool we have is to still focus on new human drivers and how and who and the process by which we determine who is given a driver's license. And that's my project this year.
Wonderful. While we are educating the machine how to drive, we still have to do a proper job, educate humans how to drive there. Adam.
So I've been an engineer for coming up on 40 odd years. And one of the things that I've noticed, and somewhat to my dismay, is that the practice of engineering, particularly in mobility solutions, has become incredibly balkanized. And what I mean by that is that engineers are forced to specialize into very, very narrow domains. And the ability to look at the big picture has really gone away. And my thesis is that with the advent of some of the new computational methods and large language models, there's an opportunity to transform the engineering process and expand people's point of view. And I'm pleased to say I think that thesis has been supported, and I'll talk about that in a moment.
Wonderful. Yeah, AI is going to be a polymath and also enable human beings to be polymaths on this. Kamessi.
Hi, everyone. I'm Kamessi.
Let me mute the someone who's speaking here. Kamessi, go ahead.
Hi, everyone. I'm Kamessi. Today, I'm going to present a summary of my PhD thesis. The topic of the thesis is flexibility in platform operations. So I'm going to discuss how various platforms, including platforms in the transportation industry, such as Uber and Lyft, use incentives to encourage flexibility among participants. So we're going to look at examples such as the wait and save option for riders, the search and relocation incentive for drivers, and the various market design and algorithm design opportunities theory.
Wonderful. Thank you. Yeah. So let's get into the full presentation. We invite Kamessi to start. Kamessi, you can share the slides now. Meanwhile, I encourage all the audience to type into the chat your organization, city, and local time so we can know who you are. At the same time, Kamessi just finished her doctorate education at MIT, now working at Weimar as a postdoc and going to be assistant professor at Stanford University in 2026. Kamessi, please.
Thanks, Jinghua. Hi, everyone. It is my great honor to be here. Today, I'm going to present a summary of my PhD thesis. The topic of the thesis is flexibility in platform operations. So as suggested by the title, the thesis studies the operations of platforms, especially the platforms in the gig economy or the so-called sharing economy space. So you can think of platforms like Uber, Lyft, Airbnb. Over the past decade, we all know that these platforms are rapidly growing in the scales and types of the services that they provide. But an important challenge that they face is the increasing heterogeneity across both the supply and demand side of the market. So for example, a platform like Uber needs to deal with all kinds of riders and drivers who cannot be matched if they are spatially far apart or if the vehicle types is not compatible. And similarly, platforms in the travel industry need to deal with customers who are differentiated by, for example, the revenue they generate, the no-show probabilities, etc. So to ease the friction in the matching process, an important lever that platform can use is to incentivize flexibility. So let me give you a few concrete examples. Uber, for example, has a feature called the wait and save option, which basically provides a discount to the customers who are willing to wait. So one can think of these patient customers as being more flexible because they are more accommodating in when the services are demanded. And because of that, the platform can potentially match them with a wider pool of drivers. Similarly, Airbnb has a feature called flexible search, where the idea is that instead of saying, I want this apartment from day A to day B, I can just say that I want this apartment for a weekend in May. So all of these are programs that try to incentivize demand-side flexibility in what and when services are demanded. On the supply side, this type of incentives are also very common. For example, Uber has all kinds of relocation incentives that try to encourage the driver to drive a little bit further to the hot zones that are currently experiencing a supply shortage. Another type of supply flexibility is this platform's use of mixed fleet. For instance, Uber has all sorts of vehicles ranging from Uber X to Comfort to Uber Black. And of course, more recently, they have also entered into a partnership with Waymo to bring autonomous vehicle into the platform. So these are features that try to enhance supply-side flexibility in what and how services can be fulfilled. So given this wide range of incentives that we see, this thesis looks at different questions under this umbrella of flexibility in platforms. It has 4 chapters that can be broadly grouped into 2 parts. In the first part, we focus on the market design questions. And in the second part, we look at various algorithm design questions for how to optimize the specific levers for flexibility. So in the next couple of minutes, I'm going to give you a very brief but high-level introduction to each chapter. In the first chapter, we look at two-sided flexibility in platforms. So given that flexibility are used as incentives on both supply and demand side, it is natural to ask how these incentives interact horizontally. So for instance, if we can incentivize a fraction of agents across both market sides to be flexible, as shown by these red nodes here, do we want to concentrate flexibility on one side of the market, or do we want to have a little flexibility on both sides? We answer this question through a parsimonious matching model, and our results reveal 2 effects that we call flexibility cannibalization and flexibility asymmetry that determine whether it is better to have flexibility on one side or some flexibility on both sides. So this heat map here visualizes the matching outcome under balanced allocation over that under the one-sided allocation. So if this ratio is smaller than 1, it means that the one-sided allocation is better. And if it is greater than 1, it means that the balanced allocation is better. So as you can see in this result here, we show that actually, depending on the market configuration, Either one of these design could dominate the other, and the difference could exceed 8% in either direction. So flexibility allocation is a significant aspect of platform efficiency. And we also characterize the typical parameter regimes and the type of platforms where we expect each effect to dominate. At a high level, flexibility cannibalization refers to a kind of waste that is happening when we have flexibility on both sides, because the platform might be matching flexible agents on one side with flexible agents on the opposite side, even under maximum matching. In contrast, flexibility asymmetry refers to the situation where when we only have flexibility on one side, it could become difficult to match the regular agents on the same side because there are no flexible agents on the opposite side to help them. More importantly, we show that costly mistakes can be made without coordination of the two sides of the platform. If a platform has two sides, two teams that respectively manage flexibility incentives on the supply and demand side, the platform overall may be trapped at this suboptimal saddle point where neither team has an incentive to change their flexibility strategy, but the platform overall suffers from a significant optimality gap. In addition to this horizontal interplay of flexibility, we also look at the vertical supply chain implication of platform's flexibility strategy. We look at a dual sourcing platform like Uber, which operates a hybrid fleet of human drivers and autonomous vehicles. And this is what Uber is doing today in cities such as Phoenix, Austin, and Atlanta. So in addition to human drivers, platforms like Uber also sources autonomous vehicles from an outside autonomous vehicle supplier like Waymo, where I'm currently doing my postdoc. So in such a setting, the dual sourcing platform need to decide how to make dispatch decisions using this hybrid fleet. So basically, how much demand to give to human drivers versus autonomous vehicles. And as you can imagine, the incentive of both the human drivers as well as the autonomous vehicle supplier would depend on how the platform would be making these decisions and how much demand they expect to get. We show that in this case, in this setting, there's actually a risk of AV underutilization because the platform has an incentive to protect the utilization of human drivers to keep them engaged on the platform. This efficiency loss could be addressed, but we need to design careful usage contract to do that. If you're interested in more details of this work, my advisor, Daniel, has actually presented an early draft of this work in a previous mobility forum, and you can check out this recording on YouTube. In addition to these market design questions, in chapters 3 and 4, we look at specific incentives for flexibility and the algorithm design question theory. So in chapter 3, we look at overbooking, which is a classic problem, especially in the airline industry. The idea is that the platform has some units of capacity, but the platform can sell more units than what it has capacity for, in anticipation that some customers may not show up in the end. So the key question is how many customers we overbook. And we look at a class of overbooking problem where the customers belong to different types, different fare classes that are differentiated by, for example, the revenue they generate, the no-show probability. So the question is not just how many customers we overbook, but also who we overbook. So at a high level, this chapter looks at the customization aspect of flexibility decisions. And apart from that, in chapter 4, we look at the timing aspect of flexibility decisions. Well, I won't go into too much detail of that. There we devise a state-dependent policy to determine when flexibility is most needed. Moving forward, I'm going to continue with this line of research around platforms, especially platforms in the transportation space, to look at the various market design and algorithm design question theory. So thanks again for coming today, and I'd be happy to take any questions later on.
Wonderful, thank you. So I will invite all the panelists to give a remark and ask question. Let's keep both the remarks and the answer very short, right? Short question. And also invite Professor Daniel Fruit, who is the advisor of the committee, to start the conversation. And also, that if you're able to keep Kamessi, stay at MIT to do a second PhD, what topic you will ask her to do? Dan, please.
Yeah, let me start by saying that I think what Kamessi's, where Kamessi's thesis really distinguishes itself is that it hits several different modeling and application approaches. Her work on overbooking fundamentally advanced the state of the art for a very technical algorithm problem, which the revenue management literature has been studying for decades. In contrast, her work on autonomous vehicle supply contracting was the first to identify challenges in designing the kinds of partnerships between companies like Uber and companies like Waymo that we're actually seeing in practice today. I'm particularly proud of how prescient her work in this space was. Back in 2022, when we first submitted the work, the editors were actually quite skeptical, suggesting that what we were studying was a science fiction problem. It was not clear if autonomous vehicles would ever really work, if they would be commercialized, if Waymo would ever have any reason to enter partnerships with Uber and Lyft. Needless to say, 3 years later, not only has the paper been published in a premier outlet, but we actually see the types of partnerships that our paper was already predicting back then. Lastly, her work on flexibility in two-sided platforms has already triggered really interesting follow-up work, which Kamessi is still closely following and very much involved in. So what I hope becomes clear about her thesis, even in just this very short presentation, is that it is really broad with respect to the areas and the methodologies where she's been able to move the needle. And if I was to do another thesis with her, I feel like each of the chapters could easily have 2 or 3 follow-ups where we go even deeper, because we've covered a lot of breadth and there's so much depth to explore. So in conclusion, I want to thank the committee for this wonderful recognition for Kamessi's work. Thank you to Jinra and the MMI team for inviting her to present today. And congratulations, Kamessi. It's a really well-deserved recognition for your work.
Wonderful. Thank you. Adam and Jamie, any?
Kamessi, I do a lot of work with and around the airline industry, and a bunch of our partners, United, Alaska, Air New Zealand. And a lot of the discussion that we have in the boardrooms centers around revenue management and asset utilization. And I'm curious if your research is equally applicable to things that have slightly less temporal urgency than matching within minutes. Because if you're talking about fleet utilization on an aircraft, you're thinking about on the order of days. And I'm just curious if you think that some of your quantitative methods have applicability across longer temporal horizons.
Yeah, I think like over time, this is one of like the things that, like I started my PhD working on, like this revenue management, like well-defined questions. And over time, like for example, the work on autonomous vehicles, it looks more like this supply contracting, which is like more long-term relationship, like long-term investment planning type of stuff. So for the work that is specific to overbooking, it's more like a short-term revenue management problem. But I'm starting to look at more like long-term strategic planning type of questions where like there are different stakeholders and each could be optimizing a different objective function, like how to make this type of partnership work. So yeah, it is becoming a new interest. And yeah, I'm sure in airline industry, there are similar opportunities to look at those questions.
Thanks. Jimmy?
Thank you, Kamessi. It's a great presentation. Just a quick comment and then a quick question. The comment is just would have a million questions and fascinating and excited to hear about your work going forward at Waymo, because I think the application as we are in the growth curve right now of autonomy, I think the implications of your research and work is going to be significant there. Question is, particularly as we're holiday season with delivery, but really thinking about, did you take a look at, or do you have any thoughts on the implications, not with passengers, but with food delivery, Uber Eats, DoorDash, which is a real, urban and congestion challenge, and does the same concepts in matching apply there?
Yeah, I think like I actually did 2 internships at Uber Eats, which is more, like in this 3-sided marketplace scheme. So I think like in 3-sided marketplace, obviously there are more stakeholders to take care of. And also, I think the kinds of levers that platform have is more limited. So for example, at rides, we have like surge pricing, like all these immediate tools for managing like supply demand imbalance. In food delivery, it is slightly more tricky. But I think there are like people use different kinds of like programs to like try to either like encourage supply or dampen demand. So I think the tools one has available in this space is much more limited.
Great. Thank you. Let's move to Adam.
Okay. So I have the unenviable task of following Kamessi, and That is never an easy proposition. It's definitely going to be a letdown for the audience here. So just go with that theme for a moment. This is a much more empirical as opposed to quantitative presentation. And what I did, just to give you a sense of the methodology, I spent a great deal of the last year interviewing the stakeholders that might have some skin in this game. So I spent a lot of time speaking with automotive OEMs at Ford, at Porsche, at Toyota. I spent time with leadership at OpenAI and Anthropic and Google DeepMind. And I spent time with individual contributors and engineers working on interesting problems. And I actually say we'll have to tell you that the conclusion was better than I'd hoped and more optimistic. So with apologies here to Monty Python, and for those of you who are old enough to remember the skit about the paleontologist whose theory about dinosaurs was that they were thin and then thick and then thin again. That's really where I feel that engineering has gone. So if you think back to the giants of engineering that we think of as seminal contributors, they were often skilled in a variety of disciplines and, brought the ability to integrate ideas across mechanical engineering and mathematics and thermodynamics and chemistry to advance the field in some profound way. And, we remember those names and we speak of them 100 years later. And I think when I entered the engineering field, it was very, very much more siloed. And I believe that, from what I've discovered and discussed in the last year, it's even more so today. So a person will design a component and pass it along to an analysis team who will pass it along to a group studying EMI or thermodynamics. And it goes round and round in this loop of a great deal of people. But I think what I've come up with is that is going to change. And, one of the comments that Sam Altman made was he's fairly certain that there's going to be a single founder, single employee company that generates $1 billion in revenue per year in the next few years. And I think a lot of that is going to come to engineering. And, when again, being at the older end of the spectrum, I started my career with a drafting board and in a room of engineers. And obviously that moved toward the advent of early CAD and now, what you'd think of as sophisticated computer-aided design and computer-aided manufacturing. But I believe that what Jinhua alluded to earlier on in the introduction is that we are going to see a renaissance in this idea of polymaths reemerging and creating great value. And if you just think about this from a timeline perspective, when I got into the engineering community, it was very analog. Even things like chip design were done on, gigantic light tables with X-Acto knives, cutting out masks on huge tables with groups of people, which obviously moved to engineers at workstations. But I think what you're starting to see is an agentic model with an engineer orchestrating the creation of solutions that encompass entire products. And I think this is incredibly exciting and empowering, and I believe will continue to accelerate sort of the rate of change in the industry. And here's some really interesting data that suggests that automation and what I would call traditional sort of linear automation, factory automation, has not had a profound impact on labor productivity. And the data is if you just look at from like 1950 to 2000, it's remarkably flat given the amount of investment that's gone into changing production lines. And you're starting to see some changes in the 2020s, but it's still a relatively low set of gains relative to the billions or hundreds of billions of dollars associated with it. Contrast that with what I'm calling sort of the upstream shift, which is that engineering tools are radically changing productivity. Again, if you look at just the right side of the curve, changing labor productivity sort of from an index 10 to into the mid 20s. And that's really in the last 5 years. And that change is, occurring daily. And I'll talk about that in a moment. But if you look at just simulation time and the time to generate workable solutions, it's really profoundly better. And when I went and spoke to the players in industry, and as I said, I met with a lot of people in a lot of domains, a couple of things jumped out at me. One was when I was talking to the folks at XPeng, they were talking about entire automotive design cycles on the order of 18 months. And when I first started looking at automotive design, a platform shift was a 7-year item. So, but again, what you're seeing is 50% reduction in development cycles, huge reduction in the number of physical items being created. If you look at on the industrial management machinery side, you're seeing radically smaller teams and significant time savings. And in aerospace, the thing that I think is most fascinating is the complexity growth and development timelines not scaling linearly with complexity. So I think you're starting to see evidence of this in what I would call the established players. What I'm particularly focused on is what is happening in next generation engineering. How are we going to think about the cycle from research all the way through the life cycle of the manufacturing, production, and operation and maintainability in the community of new products? And I think what you're starting to see is these physics-based foundational models and Gen AI having incredible impact already. And since I operate primarily in the realm of startups, and I'll talk about that in a sec, you're starting to see huge numbers of companies. This was some really interesting academic research that came out of China from Beihang University. And it was looking at the complexity of a problem and the availability of computational methods to solve them. And the conclusion was, incredibly clear if you waded through this 40-page paper, that, deep learning techniques correlate incredibly well with complexity and are producing workable solutions out of the gate. And again, in my discussions with different manufacturers, one of the things that jumped out at me was newer manufacturers were embracing these techniques far more readily than entrenched players. And actually, I think if you're, I'm going to jump Jinhua's question about what would I focus on next. I actually think the problem is not a technology problem, but rather a workforce problem. And how do you retrain people that have been in the workforce for 20 to 40 years to think very differently? When again, I spoke to people at NEO and XPeng in China, and the workforce is generally younger because the companies are newer, and they're embracing these new techniques sort of ex ante, out of the gate. When I said the startup community is focused on this, it's really fascinating. I have been lucky to participate in this sort of investment ecosystem of deep technology for the last 25 plus years. And this was a veritable wasteland. I have been looking for solutions in these spaces for decades, and it was you would be lucky to find a company focused on something, for example, on the design side, once every 4 or 5 years. Now there's literally an explosion of startups focused at sort of every moment of research, design, simulation, verification, manufacturing, and maintenance. And they're having incredible impacts already. There are companies that are addressing solutions that have not had workable answers. For example, using automation for polishing of arbitrary shapes. That has always resulted in bad outcomes. And now companies like Gray Matter are routinely taking robots and moving from a car hood to a football helmet to a guitar sequentially in high mix environments and offering fantastic outcomes. And you're seeing this in every domain from biology and computational chemistry to semiconductor design to automotive aftermarket and PLM, product lifecycle management. It's really, really profound. So one of the things I'd like to do in closing is show you a video of a company. And this video is a real-time video. And what you're going to see is an engineer has created a very crude CAD model that has some features. And in less than a minute, this software package uses Gen AI to identify the constraints, choose the manufacturing method, look at the orientation of cutting tools, create a new solution, and analyze it both in vibratory and stress-related modes and produce a report for the manufacturing engineer. And so I will show you this video really quickly, just as an exemplar of something that is taking place in all of these domains. So there is the crude CAD model, and it's uploaded to this software platform. And this is actual just screen recording. And so what you do is they choose the material, and it's going to figure out what points are immutable and are rigid. Then the engineer is going to enter into the load cases, because this is an automotive thing, where there's a mass constraint and a stiffness constraint, choose a manufacturing process, design how it can be mated. It will then optimize the part. Here is the optimized part. It came up literally in seconds. And then the engineer is able to look at the displacement under load and the stress strain calculations and produce a report that highlights cost, savings, optimization, and the risks associated with that particular solution. And as I said, this is one of hundreds of companies. And so what I believe is going to happen is that hardware is going to have this ChatGPT moment. And what you're starting to see is data going into foundation models, which create computational and manufacturing solutions that are going to create this idea of solo unicorn founders. I also think it plays very strongly into the theme of reindustrializing this country. And we're, I think, seeing the implications of that in some of the startups today, but you're going to start to see it filtering into mainstream manufacturing companies shortly. And I think, just in closing, when you have Jensen standing up saying that, you know, that the next frontier of AI is physical, I couldn't agree more, and we'll happily discuss this in greater detail at some point.
Wonderful. Given the time, I'll just ask one question and invite Jamie and so just type the comment into the chat. So Adam, you mentioned one important thing is moving from the technology discussion to the workforce impact discussion. I want to have a narrow point on here. Adam, at any higher education, there's always the debate between training specialists versus training generalists, right? Given you observe, it's always a balance, of course, but given you observe what's happening, do you think we should earn more on one side or the other? Any impact on this?
I think you need to know enough. Like, I think it's really, really useful to know something about everything, but perhaps have a specialty. I mean, I think it's enough. It's useful to know enough that, for example, I don't know anything about the level of depth that for example, Daniel does about OR, but I know enough to go to ask him. So I think it's really, really important to expose a mechanical engineer to an electrical engineering class, while focusing on the depth that you need to practice your art with skill.
Yeah, good. Thanks, Adam. Jamie, it's your presentation, please. Yeah, very good.
All right, I have the distinct challenge of going after two great presentations and speakers, and I also have the distinct challenges of looking at a process we all know has been around for a very long time. But that's really the point, is sometimes the biggest return is in the hard process of revising old systems that many of us go through. So a couple really quick facts here. We license, it varies every year for lots of reasons, but we license 1 to 2 million people, new drivers every year in the United States. It's just worth noting, this is not a system that's free. It has a lot of costs, it has some risk, and it has some vulnerabilities and subjectivities. It is a model that developed around training, driver's education, and teaching and testing, as vehicles became pervasive in the United States in the early 20th century. We live in a very different world today, as we all know, and we just heard. There's a couple things that I think are really important, which distinguishes the road test. And I spent my research really going back through this history, because to understand the future and where we should go, we have to actually understand how we got here. There is no such thing actually as the road test. There is no federal law. There is no national requirements. This is truly 50 states who individually decided how to set up a testing and licensing system. There is, strangely though, considerable consistency across the United States. That was one of the things I really wanted to double check. And there are some differences, but not as vast as you would think, particularly in the current sort of partisan environment we live in. We do it pretty similarly across the United States. The licensing model we have, the concept of a road test, began in Rhode Island in 1908. And it actually took decades to grow and to be established in other states. Classic phenomena where people gradually and practically began to add. It was focused on manual skills, and it's been remarkably stable. If you took a road test like I did in the 1980s, it wouldn't really look that different today. If you're listening and watching this presentation, you get this about safety. We have work to do. There are still substantial problems with fatalities and crashes in the United States. We also know, one, that our new drivers are the most vulnerable and risky drivers, but even more, this is from a study about 20 years ago, McKnight and McKnight. But we also know there are distinct issues and gaps in skills with new drivers. And it's important to really set that, because we live in a world where we do really want to impact what we do. And we have a road test that decides who drives that has been, as I just said, remarkably stable, consistent across the United States, and in place for many decades. So what was one impetus to really take this look is that policy is really hard to change, particularly when it's in 50 states and 50 ways. But the pandemic actually sprung a few leaks in this dam. And for really practical reasons. It was really hard to give a road test in spring of 2020. You could not get 3 people in a car with a witness or a parent or guardian and a person to administer. Different states, different things. In Massachusetts, we froze the test and then brought it back with some changes after we got through the initial closure. In Georgia, they actually just suspended doing a road test and gave licenses to new drivers on the basis of just an application, and they brought it back after a few months. Other states responded like Mississippi and permanently eliminated the road test to this day. They don't do it anymore. And the other thing that's happening, because if you just listen to the prior conversations, we're in a rapid change cycle. Our vehicles, the all the abilities and things that we do in the car, the skills that are required, they are not fixed. We're in a very dynamic change period of time. So just to visualize that, this is a 1960s Mustang. And again, think about the classic road test that many of us took. It was around even manual driving, power steering, and the classics of backing up in a straight line in parallel parking. This is the cockpit of a vehicle today. Entirely different things that we're all familiar with, we've gotten used to, but the skills are different. So I just want to cover really fast some conclusions. And again, this is sort of looking backward. If we decide who gets a license in the United States, we should have a process in every state that is reliable, legitimate, and valid, consistent. The current practice, in short, doesn't achieve this. And again, I looked at across both the research, interviews, the history of how it was put together, and the research is quite clear, and the outcomes are quite clear, that how we choose in a road test to determine if someone passes and gets a license is not a predictor of safety outcomes, and it doesn't sufficiently prepare novice drivers for modern skills. I really like this question from a study that in 2008 that New Jersey did. It just really simply gets it. Does the ability to parallel park, perform a K-turn, use turn signals, brake smoothly, among other things, mean a novice is ready to drive unsupervised? The answer for them was clearly no, although they did not change their process at the time because it's really hard to do. It's really hard to do alone in one state. So the conclusion that I reach in this research and paper, this is the backward-looking piece of it, there's a forward-looking piece to cover in a second, is that the road test does not serve as a valid predictor of safety results. It didn't actually begin for that reason or with any research to back it, and the roads have really changed, our cars have really changed, and the process has really changed. So that's the backward-looking. Here's the good news. We know what actually works, and we've known for some time. For those who work in sort of policy and licensing, the shorthand for this model is graduated GDL, or graduate driver's licensing models. There's a lot of different things that are covered in this, but this slide captures some of them. Just getting a license later saves lives, things that delay from age, because that's experience and development and ability. Nighttime driving restrictions really work. There's a couple different ones here. They all really work. Restricting who is in the car and how many people in the car for a certain period of time also really works. There's some enforcement issues that are complex and challenging with this, but again, between telematics, our phones, and all the modern capabilities, this data, which is actually quite aged, demonstrates how well this works. But going forward, we have the capacity to implement these in new and creative ways. And so I just want to end here. There's a lot of different ways and opportunities to look at how we can rethink licensing. One I just touched on, which is we can use our phones and modern technology to think about how to better administer and use private insurance and modern technology to implement either what I would call enhanced graduate driver's license models or next generation graduate driver's licensing models. These really work. They have saved lives, and we can take them to the next level. Overlapping with that is we can actually, at a state level, because these are implemented at a state level and state regulatory structures, we can really think about reforming the auto insurance market and use more tiered licensing, as it's been done in the rest of the world, particularly in Europe, to think about exit tests and staged and tiered licensing models. We would now need to marry that with more privacy and data models. One really interesting interesting idea that came up a lot in the research is what has happened over the many decades in the aviation, where we shifted from a pilot to really a supervisor of the plane because of the autopilot and other features. That is really where we're headed with all the ADAS, with all the full self-driving, and with all the features in our vehicles that we are beginning to become familiar with, which will accelerate over the next few years. And then last two things just to touch on. There is a lot of research that has been done on how simulation and particularly hazard perception training can really help new novices learn to address the skills I showed in an earlier slide that they're particularly insufficient in. These have been begun to be demonstrated to work. It's merely a question of how we could scale and implement that for all new drivers. but there's a lot of work and development on this. And the last is we actually changed the way we tested and implemented a whole new road test for commercial driver's licenses nationally. And there's a lot to consider and pick up from that model. So again, in the interest of time, I'm going to stop there and maybe take some questions.
Thank you, Jimmy. Maybe some quick ones. One is when Mississippi eliminated the test, what's the consequence, right? That's fine. The second one is when in one slide, you show that paying attention is actually one key factors. What's the difference between educate people on a skill versus educate people about attention? This and relate to this, if we were to move from driver to a supervisor, how realistic we can educate to be a good supervisor? This,
yeah. So let's Mississippi. What's actually really interesting is based on all the look I can do, both in articles, talking to people, there's been very little. You can't detect the difference in the fatality rate. Doesn't mean that the fatalities and crashes are going well in Mississippi. It just means that you can't detect the drivers that are not getting a road test in the whole field. So I would say it's undecided. I think it would take more time to see what the difference is there, but it has not caused any policy backlash there or anywhere else. Meaning the road test was done away with more a whimper than a loud backlash. On the attention, this is where I think some of the hazard perception training is really proving helpful, because what that teaches you is different ways to monitor and think about all the different hazards that you can address on the road. And it seems that there is really a lot of different ways to try to think about that. And the last point is, and again, there are a lot more expertise on this, and I really just was able to scratch the surface on the aviation model. But again, it's really a mental framework. So the training and testing from driver's education on board is to really think, it actually matches even in some of the things Adam touched on in a very different realm. The human driver is still responsible for the vehicle, even if it has full self-driving or other things. And it teaches you to be an active participant in that in a very different way. And right now, we are overly comfortable with some of the new ADAS features, and they're leading to new liabilities and risks. So it's teaching you to transition and to reimagine your role in the car. And that's similar to what's happened over a lot of time with a lot of training in aviation. And there's some hope that might be necessary, and also a way that we could actually better prepare new drivers for modern vehicles.
Nice. Thank you, Jimmy. Zhao.
Super. Okay. Okay. So let's start with Kamessi. So great. Let's see. So Steven Zoff had a question. He said, "Great talk. When you say costly mistakes, which was on page 6, can you characterize these costs a bit more?"
Yeah, I guess this type of cost varies from platform to platform. In the paper, we primarily focus on a matching objective, which is like basically they want to facilitate as many matches as possible. So it is specifically referring to that matching objective minus any cost of flexibility. But I guess more broadly, this cost refers to basically a difference in like the resulting like objective value. If one were to do like a global search for the optimal flexibility design across the two sites versus the outcome that results from like a greedy optimization by one team and another team increase flexibility penetration, like this type of greedy search. So it was referring to like a difference in the objective from these two approaches.
Okay, super. A.D. Wilson said, "Great presentation. Do you think these findings could be applied to other transportation elements beyond the gig economy? Like, could it be applied to EV charging, for example?"
Yeah, I guess like there are two interesting applications like I can think of at the moment that are beyond this gig economy space. One is autonomous vehicles is not just transforming like platforms like Uber and Lyft and creating a competitor. It is also transferring like industries such as like the freight industry, where people are thinking of, like one could complement the human network with some like autonomous trucks to complete this kind of like long haul trips where humans don't like typically prefer. So I think this is one area of change. Like in terms of EV charging, I think like there are also a lot of work where people are thinking, if people are using pricing as an incentive for people to do like off-peak charging, to do to leverage demand side flexibility, to smooth the curves essentially. So I think there are a lot of areas where similar like flexibility incentives might be at play.
Awesome. And Kamessi, if I may just throw in a question myself, you mentioned sort of the transition from like a two-sided platform, the classic Uber model where you have drivers and you have riders, to a three-sided platform, which is more like Uber Eats, where you introduce restaurants into the mix. Do you have just any general reflections for us about how the complexity of this type of model increases as you increase the number of sides of the platform?
I think in general, like different people have different objectives to optimize over. So the more stakeholders you have, the more friction there might be. For example, from the restaurant perspective, it is not clear that all kinds of restaurants would want to have would want to partner with Uber to like open this new online channel due to, for example, the congestion that it creates for the restaurant itself, the experience, like the externality that it generates for the like dine-in customers, etc. So like different stakeholders have very different objectives. For Uber Eats specifically, like the tools they have is quite limited because like if they restrain demand, it is not clear that restaurants would be happy to see it. So yeah, I think overall like the friction of the stakeholders is like one of the big issues that are introduced.
Super. Okay. Well, fantastic. Great presentation. Let me switch over to Adam. So, Adam, Robin Chase had a comment that I'd like you just to offer your reflections on, which is the implications of single polymath entrepreneur is another consolidation of power into fewer hands. No need to collaborate, no need to share benefits. What are your reflections on kind of the social implications of your
Yeah,
talk?
I I'm going to respectfully disagree. I think that at least it relates to sort of consolidation of power. I think, look, complex problems require collaboration inherently. And if you're going to design something and build something and bring it to market, that necessarily involves a village. Where I am particularly excited about this idea of empowering individuals to think more broadly and perhaps offer more skills is frankly mostly at the conceptual level, which is really getting some idea to a proof of concept stage more fluidly. And I guess what I would say is, as a proof point, when I started my first company in the early 1990s, it was required that you had to build custom hardware to run your idea, and the software was bespoke. Today, if you're prototyping something, general purpose software in the cloud works, or general purpose hardware running in the cloud is fantastically applicable to most things. And software frameworks allow you to string incredible capabilities together with APIs very quickly that I think have engendered enormous creativity. I think that's going to take place in hardware.
Fabulous. Okay. Sal Tannenbaum asked the question, are the overall statistics for productivity, which you shared, are the changes that you discussed just simply not captured? Are the statistics not capturing these changes, or are the changes just marginal changes in a much larger and less dynamic system? I guess, the core of the question is, where do you see those productivity statistics moving going ahead?
I think you're going to. I think that there's a recency bias, and I think that's really the challenge. I think if you're looking over the changes in the last 60 or 70 years, and you're looking at massive changes in the last 3, it really hasn't shown up in the data more broadly. There is a lag in collection. What I will say is, in speaking with large scale producers, they are seeing these changes. And I think you're seeing it in reality. I mean, if you look at, for example, the F-47 sixth generation fighter moving from idea to flying in 24 months. That is back to the way it was in the 50s when planes were simpler and you were prototyping things in the order of 180 days. So I think you're offering solutions that have enormous complexity much faster. And I think you see that in the Chinese automotive domain. I think you're starting to see it in aerospace. And certainly you can see it in the rapidity and cyclicality, for example, at SpaceX in terms of iterative changes to very large scale designs.
Super. And then, if I may, as a fellow engineer, I mean, you offered this wonderful example, quite vivid, of how these tools can rapidly iterate and design a particular component. My question would be, what happens when you bring that over to the production side? Do you see sort of like an equal revolution in being able to very, very quickly and more efficiently manufacture that particular component at scale?
So I think the answer is it depends. So if you are talking about, like, for example, one of the things that particular software package does that seems like a really simple idea that no one else does is when it designs the part, and you saw the changes from the very blocky to the prismatic and much lower material cost, it designs the fixturing to manufacture that part. So it creates the work holding devices, and it creates the ability for a manufacturer to not only have a better design, but a better way to build it. And that, I think, is it's a simple insight, but it's a really powerful insight, because that would be a separate thing that an engineer would have to design and think about. So I do think manufacturing for things like CNC and die casting is evolving rapidly. Whereas newer platforms like additive, the platforms are evolving at the same time as some of the design techniques. So I think it's far more nascent, and I think you're starting to see opportunities there, but it's less clear than if you're taking something that everybody already understands, like a 5-axis mill.
That's super. And Jamie, apologies. I know we're super low on time here. We're actually out, but there were, as you may have seen in the chat, a lot of questions and comments about sort of driver education. Let me just give you the last word on that.
Yeah, I actually think that driver's education is something that's actually quite expensive, really difficult for people to prioritize and make time. And unfortunately, the research says it isn't really teaching anybody any modern skills. There's even specific studies on that. And so I really want all of us to think about, you can draw a straight line, even though they're totally different topics from the prior two presentations. We live in a really dynamic world, and millions of people every year, and our teenagers are being granted licenses. So we need to actually do the hard work to think of a new way to teach. It's a huge cost. It's a huge burden. It takes a lot of time. And I really want to make sure that for the foreseeable future, we're going to be giving licenses to new drivers. Under any of the conversations we just had, they're not going away. And so we need to actually adapt to that change, and in this hybrid world, put them in a much better position to actually handle modern vehicles and modern roads.
Right. Yeah. So I'll just say the lack of innovation education is true in road tests, but also in general. I would say MIT is great in innovation in research, but in education, we still do the same thing as we did like hundreds. That's always been the case. We didn't. So that's actually like a much more generic challenge we're facing, how to update our education system. So everybody, please join me. Thank the panel, Jamie, Adam, and Kamessi. Thank you so much for the presentation.